Okay, hello everybody. My talk is on mineral nutrition for avocado fruit quality, and I'm going to present a brief review and recommendations. My name is Daryl Joyce. My co-authors are Melinda Perkins, Simon Newitt, Lindy Coates, and Stuart Irvine Brown. We work for the Department of Agriculture and Fisheries in Queensland, Australia. By way of introduction, meeting consumers' quality expectations poses a challenge for avocado producers. The inherent fruit robustness at harvest can have overriding influence on the final fruit quality and supply chains and to consumers. And differential responses are potentially linked to varying mineral nutrient levels in fruit, skin, and flesh tissues. Associations between fruit mineral status and post-harvest fruit quality have long been recognised, and among them a high fruit nitrogen concentration and or a low fruit calcium concentration, which translates into a high nitrogen to calcium ratio, have been correlated with more avocado post-harvest defects. High potassium and magnesium concentrations have also been associated with poorer fruit quality. This is an example of some work we've done in the past where we're looking at body rot expression in Hass avocado fruit that we ripen to the firm ripe stage. Interestingly, these fruit were harvested on the same day from two orchards operated by one grower and exposed to exactly the same post-harvest conditions. But no fruit from the first orchard, which is depicted on the left-hand side at the bottom, developed any body rots. In contrast, all fruit from the second orchard did develop body rots. And you can see from the panels there that the flesh nitrogen calcium ratio is only 23 in the fruits that didn't develop rots, but it's almost double in the fruits that did develop rots. So it's compelling evidence for our propositions, which are depicted in this slide here. They are balancing fruit mineral nutrient levels to optimise fruit robustness is potentially attainable through informed management of interacting pre-harvest factors, that robust fruit are inherently resistant to the expression of post-harvest rots and disorders, and that such fruit contain relatively low nitrogen and also potassium and relatively high calcium, that a low nitrogen to calcium and a high calcium plus magnesium over potassium concentration ratio correlate with greater fruit robustness. The mandate that we had for this work was from growers, really. Grower workshops and survey revealed that Australian grower avocado producers were generally aware of these putative relationships, but they sought greater clarity. So our specific objectives were to clarify the existing scientific knowledge of pre-harvest mineral nutrition effects on post-harvest avocado quality outcomes, and to summarise this for industry, to identify knowledge gaps in the existing scientific and technical literature, and to report pre-harvest mineral nutrition management strategies that potentially improve avocado post-harvest performance. The methodology was very basic and simple. We conducted a desktop literature review, but then we ran that review past international experts in the research and industry arenas. We formulated recommendations that were actionable now, and also recommendations that required future research. The report's findings have already been summarised in a Talking Avocado magazine article, which is given in the reference immediately below the text there. So an example of an output from the survey is we were looking at what is associated with more, a positive symbol, versus less, a negative symbol, fruit peel or fresh quality defects. And on the left-hand side of the table there, the defects that we've looked at are body rots, stem end rots, diffuse discoloration, vascular browning, vascular leaching, pulp spot, discrete patches, and endocarp black spot. And I've highlighted in red the nutrients of greatest interest to us, which are the nitrogen and the calcium. So just going down the column for nitrogen there, you can see that there's an increase of positive, so more defects associated with nitrogen, with calcium consistently throughout the defects, a decrease in the level of defects with a high nitrogen calcium ratio. We're seeing greater defects. That's on the column second from the right-hand side. And in the column on the far right, there's positive effects in terms of less quality defects, so negative signs for calcium magnesium over potassium ratio. How do the studies that we did on a desktop translate into decision-making tools? We've put together this relationships diagram where we covered off on post-harvest factors that are involved in moderating soil health, tree responses, fruit nutrient concentrations, and then resistance to the different defects. And just using, for example, one track, we start off with well-scheduled irrigation. That will give us adequate soil moisture. Adequate soil moisture will give us adequate calcium uptake by the roots, lead to adequate calcium transport to the fruit, be associated then with a decrease in the nitrogen to calcium ratio because we've got better calcium status, and then ultimately to resistant to defects such as post-harvest rots. And of course, we can go through, take different pathways through this diagram. So from the overall review and the detailed papers that were covered off in it, we have what's actionable now, and we can coin them as rules of thumb. So there are 6 of them here. The first one is to provide adequate calcium to trees, especially during flowering, fruit set, and early development. To conduct fruit tissue analyses as a relatively reliable indicator of fruit calcium concentrations. To ensure that leaf nutrient concentrations for nitrogen and potassium do not exceed the upper limit of their optimum range. To delay potassium application until later stages of fruit development and then only apply it if needed. To seek to realise good balance between vegetative growth and crop load, and to select appropriate rootstocks when establishing new plantings. Those activities requiring further R&D are listed here. There's 11 of them. We think that looking at big data, nitrogen and calcium data sets will help a lot towards understanding G by E by M, genotype by environment by management interactions. Looking at production environment practices that have been associated with good versus bad nutrient status is also another way of looking at the available data sets. Management of irrigation to maintain good water relations, but also apply things like RDI where we need to manage fruit size, for example. Holistic approaches to nitrogen management so that we know where the calcium is in the profile, when it's available to the roots, where the roots are. So a very integrated approach to nitrogen management. Exploring further utility of compost and mulch as an amazing buffer zone within the soil, excuse me. And that will buffer moisture, nutrients, and also beneficial organisms that also suppress phytophthora root rot. Then there's soil application of additional calcium at fruit set, which is the best time to get calcium into fruit. Then there's the timing and type of fruit tissue sampling for nutrient analyses. So some relatively recent work in California has looked at the cauliflower inflorescence stage in crops. There's a rapid diagnosis for monitoring fruit nutrient status. If we can find lower cost, more effective ways of measuring nitrogen and calcium, then we can get richer data sets. The use of plant growth regulators is an ongoing issue. Where it's approved, it's very effective for managing calcium canopies, excuse me. And then the relative susceptibility of flesh to bruising. So we've seen effects on other defects, but we've got evidence, quite strong evidence that a low nitrogen calcium ratio improves resistance to bruising. And then the influence of the graft union per se versus rootstock type on the uptake and translocation of nutrients is another area for potential some more work. The physiochemistry of calcium application in fruit is of interest to our group. On this left-hand side panel here, we're just looking at on the right-hand side of it, the uptake of water, and with it, the uptake of calcium. So everyone's very familiar with that kind of scenario, moving from the soil through the root to the shoot to the fruit. So, but the important drivers at the soil root interface are adequate calcium supply and active root growth, and restraints are things like low soil pH, competitive cations such as potassium, and also poor soil water relations, either too dry water stress or too wet water logging. Then moving into the plant itself, the drivers are transpiration and root pressure as well to get calcium into the plant and through the plant. And then restraints are things like binding of calcium to the xylem vessel wall, slowing down its upward movement through the plant. Then we get into the shoot and particularly the fruit. The drivers for getting calcium into the fruit are fruit transpiration, but also fruit growth during that rapid fruit growth phase. And then also auxin export in terms of sink strength for any active calcium accumulation that might be occurring. And then restraints are things like excessive vegetative growth in relation to the canopy, so that transpiration drawing the calcium to leaves rather than fruit. One of the devices we're using in our studies is the sap flow meter to try and understand the relative distribution of water flow and therefore calcium. At least that's what we're looking at within the leaves and fruit. So from our studies of the literature, we've basically proposed to industry this sort of informatic, which is integrated orchard practices for improving fruit quality through mineral nutrition. We're arguing for robust avocado fruit, which will then give better quality outcomes for consumers. Just looking at the diagram from the bottom left-hand side, going around in an arc to the bottom right-hand side, we argue that we need to manage phytophthora root rot, so we've got active root growth to improve soil organic matter for improved disease control of phytophthora, but also for improved water holding capacity and improved nutrient availability. Making better use of the fruit nitrogen calcium ratio as a key indicator of fruit robustness at harvest. Looking at the timing of pruning to avoid vigorous reproductive growth, especially during the flowering and early fruit development stage. Choosing appropriate root stocks, and there's some evidence that suggests that the Guatemalan and West Indian root stocks give you a better nitrogen calcium ratio in the fruit. Avoiding competition with potassium, so delaying its application until later stages of fruit development. Carefully managing the nitrogen rates and timing so as to avoid that competition of leaf growth with fruit development and maturation. And then maintaining, of course, soil calcium levels as high as possible, and also soil moisture, especially during that first 8 weeks of fruit set. And in conclusion, in closing, I'd just like to acknowledge the funding body that has supported this LIT review, which is Hort Innovation, but also we have support from the Queensland Government and the Australian Government. The full review will be duly published on the Hort Innovation website and available to people who have access to that. And I'd like to re-thank the reviewers and the colleagues who went through our review and contributed advice and guidance. And with that, I'd like to conclude this presentation and invite any questions or comments that might be coming my way. Thank you.